Okay, hello everybody. I'm going to give you guys a little trip down memory lane to way back when you were in 5th grade, maybe 4th, maybe even 6th, and learning how to multiply larger numbers. And your teacher may have taught you how to multiply numbers by using an area model. So we like to call that the distributive property. So if I have the number 34 times 26, many of you know how to multiply those numbers using standard algorithm or a calculator. But when you were first learning, your teachers taught you how to use the distributive property. So we had 30 plus 4, and we're going to multiply that by 20 plus 6. This is essentially what we're doing with polynomials. Exact same thing. So your teacher would have had you maybe write 30 plus 4 at the top, and along the side they may have had you write 20 plus 6. Now I'm going to put the plus in front of the 6, and we'll see why in just a minute, because when you start working with negative numbers it can be a little tricky. All right, so there are many strategies that you can use to multiply polynomials. I find this one the easiest. So again, most of you are looking at this going, oh my gosh, I remember doing this. 20 times 30 is 600. 20 times 4 is 80. 6 times 30 is 180, and 6 times 4 is 24. And then your teachers would have you add all this up along the side. This is called combining like terms, folks. The thing is, they're all the same terms. So when you add them all up, you get the answer 884. Okay? You did this back in elementary school. Well, guess what? Polynomials work the exact same way. So we're going to use an example. This came right from your practice problems, lesson 6. And I gave this as feedback to many of you. But if you go into lesson 6 and you look at practice problem number 2, okay, the video's in there. If you have the workbooks, you can work this out. They give you the polynomial x plus 1 times x plus 3 times x minus 4. Now, I've never taught Algebra 2. I'm learning this as I work through this with you guys, giving you feedback, grading your work. And I'm looking at this right here, and I'm just going to connect it really quickly to graphs. I know my zeros, right? Because if I have x is negative 1, that would make 0. If I make x negative 3, that would make 0. And if I make x 4, that would make 0. So if I were sketching a graph of this, I would know my zeros, right? So just pointing that out because that actually came up in another one of the learning checks that we did. All right, when you have 3 factors, it's easier if you multiply 2 of them first and then the third. So again, if you had the number 2 times 5 times 6, you would multiply 2 times 5 and get 10, and then do 10 times 6. Or you could do 5 times 6, get 30, and then do times 2, and that would be your answer, 60. That's the same thing here. We're not going to try to do all 3 at once. So I'm going to start with the first 2. This is just my strategy. I look at the first 2 and I go, okay, I want to multiply these 2 together. And I'm going to use the area model because letters and numbers together get very confusing. So I have x plus 3 at the top. It doesn't matter which one you put at the top and which one you put at the bottom. That's the commutative property, right? Okay, so I'm just going to put x plus 3 at the top, x plus 3. It's not lined up exactly, but that's okay. And then x plus 1. When I'm using this strategy, I want to make sure I give myself room. So if you need to make your box a little bigger, if you're, write a little bigger, I'm keeping my positive number with my 1. And I probably should just maybe move this over a little bit. And I'll show you why. Because there's a negative 4 here, so we're going to get into that. I want to keep the sign with my number. So this is x and a positive 3. This is x and a positive 1. Okay, yes, it's plus sign, but it's also the positive sign. Okay, so now I do the same exact thing. X times x, that's x squared. X times 3, that's 3x. 1 times x, that's 1x. And guys, look, if you need to put the 1 in front of the x, you can do that. I do it to help myself remember that it's 1x. And then 1 times 3 is just 3. Now this is nice because everything's positive. So now that I'm done, I'm going to do the exact same thing I did way back in elementary school. I'm going to list them out and I'm going to combine like terms. So I have my x squared, I have my positive 3x, I have my positive 1x, and I have my 3. This is Algebra 1 right here. Okay, so I have my x squared. I can combine like terms. So I'm just going to kind of show you that these are like terms right here. Positive 3x and a positive 1. I can't combine my x squared because it's a separate term. I can't do anything with my 3 because that's a separate term. There's no variable. This is a x squared. But I can add these two together. So my 3x plus my 1x becomes a positive 4x and a positive 3. Okay, so I'm done that. If it were just this problem, we'd be finished. However, we have a third factor. And so I need to take my new product, which is what we did up here, 2 times 5 is 10. So this would be like 10. I need to take this new product and multiply it by my x minus 4, x and a negative 4. So what I would do is I would put this at the top, and I would give myself a nice long box. Okay. And I have my x squared, which is positive, a positive 4x, and a positive 3. So I have 3 columns here. And then I'm multiplying that by x minus 4, which is a positive x, but a negative 4. See how I'm putting that negative sign down there with the 4? Okay, I'm going to do the exact same thing. X times x squared is x to the third power. We have 3 factors. So again, this is another way how I already know that my polynomial is going to have a degree of 3 because there are 3 sets of x's. Okay, x to the third. X times 4x is 4x squared. Okay, because remember, this is 1 in front. This is 1 in front. Okay, and 1 times 3 is 3. But there's an x, so I have 3x. Okay, I have 1x times 3, 3x. Okay, down at the bottom, be careful because this is a negative. Negative 4 times a negative 1 is a negative 4. So this would be negative 4x. Negative 4 times a positive 4 is negative 16x. Oh, this would be x squared. Sorry, look, 4x squared. Easy to mess up on those, so double check your x's. Okay, negative 4 times a positive 3 is a negative 12. Okay, so just go through and double check and make sure you did all your multiplication correct, because that is like that little mistake that I just made where I forgot the square. That's an easy mistake to make. It's also an easy mistake to mess up your negatives and positives. So just remember, when you have one negative and you multiply it by a positive, the answer is going to be negative. If you have 2 negatives, the answer is going to be positive. 2 wrongs make a right in math. Not in the real world, but in math. Okay. Now I have a mess here. I have to organize. Just like I did back in elementary school, I'm going to list everything out, just like I did here, and I'm going to look for where I can combine like terms. So give yourself plenty of room. I have an x to the third. I have a 4x squared. I have a 3x. I have a negative 4x squared, a negative 16x, and a negative 12. All right, big old mess. Let's organize. We're going to combine like terms. So I always used to teach my 8th graders to use colors. I love colors, so I'm going to go through and look for like terms. So I only have 1x to the third power. That is my degree. So when I'm thinking about my graph, I know it's going to be up, down, up, or down, up, down. Now this is positive, so it's going to be in a positive direction. Okay, now let's look for our like terms. So I have a positive 4 to the x to the second power. Notice I'm circling the 4 and the plus sign because it's a positive 4, and that's important because the other x squared is a negative 4. That's a 0 pair. They cancel each other out. Positive 4x squared, negative 4x squared, 0. 0 pair. Okay, so they're done. Gone. Okay, that's my one pair. Now I see I have another like pair. I have a 3x, and notice I'm circling the positive in front of it. Positive 3x, negative 16x. That makes a negative 13x. Okay, so a positive 13, negative 16, that's a negative 13x. So I'm just going to record that, negative 13x. Now, I have my negative 12. I'm just going to go ahead and bring that down because there were no other like terms. There's no other numbers without a variable. So he's the only one. I just fixed this set and then my x to the third power. And I'm finished. I just simplified my polynomial. Okay? A little bit of work, but if you just take your time and think of it just like you would a normal number, 2 times 5 times 6. If somebody gave you that math problem, you'd whip it out really quickly. So yes, we have some letters. Yes, we have positive and negatives. But if we organize ourselves, we'll be able to do this problem. And again, as you're solving the problem, also think about your graphs, okay? So now I know, like in my mind, I'm saying to myself, okay, I know that this is the leading coefficient. It's positive, it's a 1. I know I'm going to have 3 degrees, right? So if I'm thinking of my graph, it's going to be like up, down, up. There's going to be three kind of flows to it. I know my zeros are going to be a -1, a -3, and a +4, okay? So connect those things that you're learning. And if you have another strategy for solving polynomials, please feel free to use them. But if you're struggling, take a little trip back in time to 5th grade and think about when you used to multiply 2-digit numbers using the area model. Same thing.